Hi, so welcome to the session on cloud native backup of Redis application on Kubernetes. My name is Ravi Jagannathan, and I'm part of the VMware team that helps customers onboard Kubernetes. So I'm part of the Kubernetes solutions engineering space within VMware, and many of our product lines are integrated into Kubernetes today. So let's take a look at the agenda. We're going to be talking about backing up and restoring a Redis application with Velero. We'll talk about cloud native backup and how it's different from traditional backup, where you back up traditional file stores or artifacts or individual volumes. We'll talk about Velero itself, its history and where it came from, and how it's been part of the community and integrated well with Kubernetes landscape. We'll talk about a sample app, which is what we'll demo. So we'll describe the sample app, the architecture of it. It's a PHP Redis master slave application. So it's using Redis master and Redis slave. And it's a simple app to kind of understand and deploy. And the code bases are all on GitHub, and there's a supporting blog for those of you who want to kind of go to this at a leisurely pace. All the detailed steps are in the blog, so don't fret. We'll showcase the blog in the useful links section. So sample app is a PHP Redis application which will back up and restore using Velero. We'll of course demo that and tell you some of the nuances that you'll have to watch and how these things work in the back. So let's get started. So with cloud native backup, the word cloud native is very prevalent today, especially in this space where legacy applications are being decomposed into smaller microservices and smaller container-based workloads. So legacy applications which would be running on a virtual machine previously would be decomposed and is now starting to run as containers. And that's predominantly the pattern that we are seeing today. Is everything is getting containerized. There are applications that use a lot of state and databases, much like Redis, very popular, to consume and kind of keep the data in place. And so these applications are called stateful applications, and there are also stateless applications, but they manage state differently. But predominantly stateful applications means there's a backing database to support this application, and 9 times out of 10 the backing database is using some sort of a volume or a persistent volume claim to kind of mount in places where it needs the disk. So backup and restore is hard on Kubernetes, and coming from a traditional mindset of backing up restoring file systems or typical files, tar, zip, right, and volumes, block storage. It's a different shift when it comes to Kubernetes, because in Kubernetes, your application itself is decomposed. It's in multiple pods and many services, and the notion of an application is very decomposed as such. So you have persistent volume claims and a microservice and applications which would consume a type of a database would now start consuming multiples or multi kinds of databases. So it might have a NoSQL, it might consume Redis, which is very popular amongst developers for key value store, as well as streams and others. It can consume some like a graph database, it can consume some like Elasticsearch, right? So typical legacy app being decomposed into microservices means you're looking at multiple ways in which they can consume data sets, and that means backing up and restoring operations are now more complicated or need a lot more nuance. And the central master that understands the state well within Kubernetes is etcd. So Velero ties into the Kubernetes control API and understands etcd and understands how to kind of go over it and carve out and understand the dependencies and mount points and such like that. It makes it easy for operators. So coming from a traditional operator background, CREs, SREs, DevOps folks, and database and systems administrators, the questions that they get asked is, can you back up my database on Kubernetes? And can you back my data sets? This is my database, this is what it looks like. Oh, by the way, my data a base is not just one instance, it is multiples. It's a cluster of instances, pods working together. And often that they're struggling with how can they now apply the same principles that they had on a legacy kind of infrastructure and carry it over to some like cloud native Kubernetes. So that's where Velero starts to help in. And one question that comes up when such workloads are going into production is the operators are, if they're confident of they can restore, backup and restore such database of such applications which are decomposed, then they are able to support such applications into production. So they are tasked with can you help us with auditing trails of these databases? Can you help us with compliancy? For them to do that, they have to understand how to kind of backing up, restoring these operations are very critical. So if they're not able to get to that stage, then they may refuse, or they may make it mandatory. They may put some objections in front of you, saying, hey, I don't know how to back this up on a Kubernetes platform. I know how to do it traditionally, but here this is much different. Backing up and restoring operations also comes into play when you're trying to migrate from cluster to cluster, or from on-prem to a maybe cloud-like scenario where you take an application and from that cluster on Kubernetes you want to kind of port it to a newer version of the same Kubernetes. So these are some nuances and challenges that come into the minds of operators. How do I do it? What can help me here? What are the tool chains available? And so one popular thing that comes up again and again to kind of help us here is Velero. So Velero has been in inception for a few years now, I think 4 or 5 years. It's a pretty solid tool. It was first developed for Kubernetes. It came out of the team that was formed in Heptio, and Heptio again is now part of VMware. So these teams are now funded and kind of helped and supported by VMware. So many of the top contributors and people who are sitting on the governance for Velero are VMware employees. And Velero understands Kubernetes front and center. It is able to run inside Kubernetes as CRDs, custom resource definitions. So it understands the nuance and how to pull artifacts, how to kind of discover the dependencies of an application, how to understand the mount points, the critical areas in which the backup needs to happen. Velero is very well versed with it. So it is popular in Kubernetes distributions on your popular cloud bases like AWS, Google, Azure, and as well as in on-prem version on vSphere. So it has hooks, pre and post hooks, to help you kind of run custom scripts before you backup or after you backup. These are very handy once you understand how some of the database need a little time to kind of be more thread safe, and collect the data and data sets in a kind of, then you can back those kind of data sets. They can also, Velero has a cron-like interface on the command line. You can schedule future backups and restores. So it has a cron-like, parameter-based command line, help, where it can pretty much set a backup and restore operation in the future. It helps between migration of clusters as well as on-prem to cloud, and there are many use cases which are very common where Velero has backed up something on-prem or in one particular cluster, and then you restore it to another new cluster or on the cloud, and these are patterns very common where you upgrade a cluster or you patch a cluster or you want to kind of save in the last known good state of an application so you can recover from an outage. These are very traditional uses of Velero. Then you have the extensibility of Velero with plugins. So in the sense that you can extend it if you see a particular operation for a particular kind of block or storage or data set, you can script that out and you can integrate that with Velero. So Velero will offload that and your script can pick it up and do the custom whatever integrations that it has to do. So many popular plugins have been written and they are up there in velero.io. You can take a look at that. So by and large, it's a good idea to have a backup and restore policy or a strategy for your application and practice that from the start, so it keeps pace with the growing application. So one application may have a few handful of pods to start with, and suddenly you'll feel over the versions of the application it runs across many pods and many clusters even. So to constantly backup and restore gives the operator the confidence that they can pretty much recover from an outage, and they're able to have that confidence going into production. So let's take a look at the solution, the demo solution, right? So in our demo, we'll showcase an app which is the guestbook application, which consumes Redis data store, so Redis master and slave. And guestbook itself is written in PHP, so it's a PHP front end using a Redis master and slave backend database to persist its data. And Redis itself is using volume and volume claims, that means data store, to kind of persist mount points and data in it. So Velero is the other application that we'll showcase. So Velero server runs on your cluster, and your operator is talking with a Velero client to the Velero server, and Velero then will talk to the etcd database in the master and kind of crawl and know how to back up this particular application. So it has all the intelligence in it to kind of do this. And once it's done creating the backup as a tar or whatever artifact, it needs a S3 compliant bucket to store. So in our case, we are using Minio, which is a very lightweight S3 compliant bucket that you can run locally. You can also integrate Velero with something on AWS, S3 bucket, or I've seen other people use Ceph and Rook to kind of drive the same thing. But for our needs, S3 Minio is great. It's very solid, it's rock solid, and we're just running it as a very minimal setup for us to take a look. So this kind of completes our solution architecture, and this I feel was something that everybody could understand, relate to, very simple in its design, and you could take elements of this and use in your data center or platform. So an operator would come in, or a developer or whoever that is, could initiate a few commands and get to a known good state of an application. Velero create the backup, so it'll go and ask for what namespace you want it for, and you say okay, guestbook namespace. It goes and talks to the etcd database, crawls the API dependencies, and comes to a conclusion of how to best kind of back this up, and does the backing up in artifacts and stores it in Minio. And then when you say Velero restore backup from this backup that you created, it knows how to do that too. So it's a very simple operation, and these are simple setup that we can describe. Going to my console here, and let's describe this for you. So I've logged into my cluster, Kubernetes cluster, and our cluster of choice is TKC3, which is where it defaults to the namespace guestbook. So once you do kget po, it basically is talking to and showing us what is running inside the guestbook namespace. And guestbook namespace is it's running our guestbook application. It's a very simple application. Let's go and take a look. So I'm here on the jump box that opens the guestbook application, and if you see, it has a particular IP, and this IP is part of the load balancer type. So it's exposing its services to the outside world at this particular IP, and it's called a load balancer type service. So it's browsable. So you're able to see we have put in some guestbook entries here. These are just random entries. Let's put in one. And you see that it's able to store these entries. So it's storing this on the Redis backend database. So there are two, Redis master and Redis slave. That is what this front end is using to integrate. And Redis themselves are mounting or claiming a volume from the underlying infrastructure. Let's take a look at that. So to take a look at Redis application mount points, let's open the YAML file, which is how we deployed them in the first place. So this is the master Redis master service. It's just a cluster service, and the application, the container itself. So you see this image, container image for the Redis, and here it is, the volume mount points for the data that it stores. It stores its data in this particular path, and this is what we'll tell Velero at some point through annotations to look for this particular mount point and store contents of this inside. So this is called Redis master data, and it's a mount point where the volumes are mounted, and the volumes are claimed by this persistent volume claim called Redis master claim, which we have already deployed. Again, all these code bases are on GitHub, and they will be on the Medium blog. So this is the slave, Redis slave. Similarly, on Redis slave you find the same pattern. So again, the image, this is the image that we are using, and again it has a mount point of data and a /data, which is where it's storing all its data sets in, and again it is consuming a volume claim called Redis slave claim, right? So this kind of describes the Redis. Now we have gone ahead and applied annotations, so we can tell Velero, once we constructed the application, we've gone ahead and applied some annotations on it, so that we can tell Velero where to go and fetch the particular, or look for the particular data folders, and to back them up. So once you create a backup with Velero, Velero will go and know this particular mount point has the data items which Redis stores, and it'll back it up into artifacts. So we install Velero through this client. So you go to velero.io, download a client for your machine. In this case, this is Ubuntu, and feed it command line parameters. So you're telling it the provider is like AWS, and we are not using anything specific to AWS here, but it's just the type of plugin that we're using. And then your bucket, where is your S3 bucket? So it has a credential in this credentials file that I've gone ahead and created beforehand, which has nothing but the Minio user ID and password in it. And this is the S3 kind of link or exposed URL to talk to Minio. So you're creating, once you install it, it'll create the Velero namespace, and then create those CRDs with which the pods start running. So let's go and probe the particular namespace. kubectl get pods, that's a short form namespace. Wait, let me kubectl get pods namespace Velero. So now you see Velero is running in its own namespace called Velero namespace and has two again it's a very simplistic instance running one of one. It is running a Velero server and which is in a pod, and it's running a RESTIC file system kind of backup recovery tool, which is again running in another pod. So these are two things that are running in the Velero namespace, and they comprise the Velero application server. So Velero application server is running inside your cluster called TKC3. So is the guest book namespace, which is running inside the same cluster TKC3, which has I think 3 front ends. So 3 front end pods and 1 master Redis pod and 1 slave Redis pod. So at this point we have all these applications running. So we have got Velero configured and installed. We've got the guestbook namespace running, and the guestbook namespace is using PVC persistent volume claim. So you see the Redis master claim, which is bound to 1 gig capacity, and the storage policy it's using is Project Pacific, which is the vSphere 7 on Kubernetes on vSphere 7 product name, beta product name. And so Redis slave is again doing the same thing. It has a persistent volume claim of 1 gig again, and the storage policy being applied on that particular vSphere. And so these are all 1 gig here, but ideally there would be multiples, hundreds of gigs and even terabytes, very common, and they will be not running in one instance. They will be HA or highly available and run multiple instances of master and run multiple instances of slave, and will running in a cluster setup. So that's exactly how they will work in production. And because this is a non-prod and this is a demo setup, this is a simple one instance kind of for the sake of demo. So now we got the persistent volume claims, you got the application setup, you got the Velero server. So let's probe Velero client get backup. So you see there's already 2 backups, and we'll open Minio again and show you. Velero's client has communicated with the server to create this backup on April 29th, and this guestbook application has is basically the artifact that's sitting in Minio, but it is the namespace backup of the guest namespace. So that's the PHP Redis application that's backed up. And remember, with Redis we had annotations which we applied on the pod. So let's describe the master pod. Okay, describe pod Redis master, and if you see it should show up the annotations that we applied at some point here. See this, these are applied, and again the code base and the blog will have the details of what the command is. It's kubectl apply, I think kubectl annotate command, and this is telling Velero where the mount points are and what exact folder to go and look for when doing a backup. So we have told Velero through annotations where are the places to backup in terms of data sets for both Redis master and Redis slave. So you can see the same thing on Redis slave. Okay, describe pod Redis slave. and you should see another annotation. Oh, sorry, a lot of typos going. So K describe the slave, Redis slave pod, and again if you see we have told Redis how to where to backup, what folder, what mount pointer backup within the Redis slave. So we've told Redis, we've told Velero what to do through annotations, and Redis master and slave are now kind of using the persistent volume claims to store the data. Now, let me describe kubectl exec. Sorry. Okay, so I'm trying to maybe port forward the Redis master so I can interact with it, which will tell us how to okay. So now at this point what we'll do is get namespace, and you see the namespace, we'll go ahead and delete this namespace. K delete namespace, guestbook namespace. So this will automatically it of course is deleting all this, and Velero server will notice that and bring it up. I'll give it a minute for it to go down. It's taking a while only because Redis master and slave, even though they're not heavy, but they have to kind of unmount, delete, and do all those operations. So it takes a little while. So what we are doing is we're deleting the application. We've told Velero to take a backup, which we've gone ahead and done the backup before, and now we're going to restore it. So it got deleted. There should be no, see, this should not work anymore because it is so take this and open that into another browser. So it is gone. So you see this namespace doesn't come up anymore. Now to restore it, so this is how we'll restore it. See, the guestbook namespace is back again, and it is taking, so what Velero is now doing is taking the last known good state of the restore from here, which is Minio, literally, and it has a restore folder or restores. So it's basically restoring this into the new created namespace again. So it knows that namespace is gone, everything underneath the layers is gone, because it's talking to the HCD server, and it came to know that hey, nothing is there. So it goes and recreates everything from scratch. So your namespace, your get service is back up. See, the IP address itself is different. So if you saw the IP address previously, I think it was 45 maybe. Let me check. So 41, it came back in 41. Let's check. So I think previously 45 was being used, right? And this is coming from cache. That's why it's not showing any data here. But if we did 41, we will be able to get to the same data state. So get pods. So all the pods are running. So you have front end and master and slave. So the front end and master and slave have been, they are new pods. So if you see the master, let's take a VKSSF. So they are exactly the same. This is from the backup. So now go to the browser and say 41. So this is the last known good state. So if we see, let me zoom in. So I'd created this was a single entry at that point, and then took a backup, and it has restored from its artifact on S3. It has restored that last known good backup into my cluster. So in a sense, we've demonstrated that it has come back to life because we deleted here, right? After getting after we queried the namespace, we found that it was there. Then we initiated a delete command of the namespace. That means everything underneath the layers in that namespace was gone. So essentially, the guestbook, the Redis master, the PV, the service, everything else in this namespace was deleted. And that's that could be a common occurrence. Somebody fat fingered it and typed it and it deleted. Now whole thing has been deleted. If we didn't back up and didn't have Velero to help us, we would be in a soup, only because we don't have anywhere to restore it from. But now, because of Velero, just one command, restore backup, is able to bring everything back to the last known good state. Yes, we should have repeatedly taken backups so that we could have recovered from the most recent, and that's where your cron schedule kind of comes in. So you can initiate the backup at repeat intervals so that you get to a last known good state. So this kind of demonstrated the fundamentals of backing up and restoring, and the blog itself has a lot of details which you can take a look. So in essence, as a 3000 feet view, the guestbook app we installed, and the Velero server and the Minio server and the Velero server we installed CRDs, and that means you need a cluster which is capable of at least creating 2 different namespaces. Then you have a client machine where you have Velero CLI, which can now initiate the installation and the connection into Minio. So you have a Minio namespace, you have a Velero namespace, and you have a guestbook namespace. 3 different namespaces. Correction. So we saw the demo. We took a look at how this happens underneath the layers. So a lot of nuance there was Velero has RESTIC. It goes and talks to HCD, crawls through the discovery API mechanism to see that particular namespace, backs it up, and when you do an restore command, it knows exactly how to do and get back to the last known good state. And so this kind of gives you a gist. Some of the useful links, of course, velero.io. You can go read about Velero guestbook app if you click on this link, and I hope this PowerPoint is shareable. You can get to that. There's a Medium blog, and if you're not able to get to it, just search for backup and DR on K8. My name again is Ravi Jagannathan. It should be able to list you through the sets of series of steps, installation, the configuration of Minio, the configuration of the guestbook application itself, what YAMLs to apply, and supported again via GitHub repo. Newsstack recently had an article where they were talking about Dell Power Protect, which is a database data set, what do you call, disaster recovery solution, uses Velero underneath the layer. So that's a commercial project that's using the kind of community driven kind of project underneath the layers for it to do its work. And because it's doing some things on cloud native, it needs to understand cloud native. So instead of writing that again, you'd rather offload it to Velero or use Velero libraries for you to do that underneath the cover. So it's kind of a good example of reuse. And lastly, my employer, VMware, we are investing in Kubernetes a lot, and that's how we see a stream of acquisitions, Heptio, Pivotal, and others. We're all doing a lot of work with Kubernetes, and that was why I was motivated enough to kind of talk about this. So hope you enjoy your conference, and thanks a lot for the opportunity to come and talk to you guys. Thanks a lot.